with her pinny.
It seems a bit mad to take all of this really expensive, really precise instruments and put them onto an aeroplane, but actually it's really genius. By putting those research, lab instruments on a plane, you're able to make really high precision observations of what's happening to the chemistry of the air. Hello. I'm Alex Archibald. I'm a member of the physical chemistry rig, and in my group we make measurements with numbers. So my research tries to understand the role of chemistry in the atmosphere, and so there's a lot of chemistry going on all around us right now. Hundreds of thousands of different compounds all interacting with radiation, and we're trying to understand how some of those compounds could be contributing to climate change and how climate change as well could be contributing to the chemistry of some of those compounds. So the way that we do our research is to use numerical models. So we have very complex models which simulate everything that goes on in the atmosphere. We also use observations to understand how good our models are. And so we use observations from ground-based measurement locations. And then we also make measurements using aircraft. And so this is a really nice, exciting platform that we have to understand what's going on in the atmosphere. So the idea of the lab on the plane is that it allows us to sample in situ what's going on in the atmosphere around us. By putting instruments on a plane, we're able to intercept different air masses and fly through the air and understand the vertical and horizontal spatial gradients of different species that we might be interested in. Well, this is really important for, I guess, 3 reasons. One is because it's just really interesting. There are literally, as I said, hundreds of thousands of different chemicals in the air. As we're breathing in now, we're breathing in hundreds of thousands of different chemicals. What are they? That's what we're trying to work out. The other reason is, though, that all of these things might affect climate change and might be affected by climate change. And so we want to know this coupling. And the last reason, which is really kind of in vogue right now, is the role that chemistry in the air is affecting our health. So this is the so-called air pollution. And so we're interested in knowing if the compounds which are reacting in the atmosphere can contribute to poor health. So doing a PhD here can be really fun. For example, we've got students who are working on combining observations and modelling, so they're getting out into the field, making real-world measurements of what's going on in the atmosphere, and then using the sorts of models that we develop as well to understand those data. And we've had people who've worked on volcanoes and looking at what's coming out of volcanoes, so those gases as well. So people have gone all throughout the world studying PhDs. Well, it can go pretty low. So over the ocean it can go as low as 50 feet above the surface. It's pretty terrifying actually to fly that low. It feels like you're going to crash. Over land it kind of depends where you are really. You don't want to fly low over London and hit into the Gherkin or anything like that. Thank you.